All right, so welcome to Scholars and Associates. Today we'd like to continue with the types of cash flow. The types of cash flow. So in our earlier discussion, we talked about the annuities. So types of cash flows. We talked about the annuities. The annuities or the uniform cash flows. Right, we talked about annuities. So today we'd like to continue with the arithmetic. Arithmetic gradient. Arithmetic gradient cash flow. Right. Then we move to the geometric gradient cash flow. Geometric gradient cash flow. Then we go to the perpetuity. The perpetuity cash flow. All right, so let's take the arithmetic gradient cash flow. Arithmetic gradient cash flow. So with arithmetic gradient cash flow, that is where equal amounts paid or received is increased or decreased by a specific amount. By a specific what? Amount. So equal amounts paid or received is increased or decreased by what? A specific amount. A specific amount. So here, decreased or increased by a specific amount. A specific what? Amount. Let me use. The keyword is specific amount, right? Specific amount. All right. So you are having an equal payment or equal cash flow, and this increased by a specific amount. What do we mean by a specific amount? So let's say 200 cedis is a specific amount. Any amount you can mention, 500, 5,000, 5 billion, every amount is a specific amount, right? Unlike a percentage, the percentage would go for the geometric, where it increase or decrease by what is a rate or a percentage. Then we can say that is a geometric cash flow. But then if it increase or decrease by a specific amount, then that is arithmetic gradient. Arithmetic gradient. All right. So what is the formula for the arithmetic gradient? Yeah, that's the formula. What is the formula? Using the arithmetic gradient, we have the present value, and usually the arithmetic is applied on the present value formula. So we have the total present value. Total present value is the present value of the annuity plus or minus the present value of the gradient. Present value of the gradient. So now, what is the present value of annuity? That is the same present value that we know. The A over the interest all over 1 plus I exponent n minus 1 all over the same 1 plus I exponent n brackets close. And this is always at the end, right? It is at the end. So if it's at the end, we don't bring the 1 plus I. We don't bring the 1 plus I by n, right? And we can then continue with the present value of the gradient. What is the present value of the gradient? The present value of the gradient is k over I squared into bracket 1 plus I exponent n. All of this multiplying into bracket 1 plus I bracket close exponent n minus n multiplying I minus 1. So this is the present value of the gradient. So if you want to get the present value of the total amount, you find the present value of the annuity plus or minus the present value of the gradient. Then that gives you the total present value for the gradient. So here the k is the constant. Towards change. The k is the constant towards the constant change. So example, let's take an example. For example 1, Kojo receives 1,000 salary every year. Kojo receives 1,000 cedis salary every year, right? So the every year makes it what annuity. The every year makes it what annuity, right? Every year, full stop. His HR has decided to increase or decrease. No, to increase, right? You can't say increase or decrease. It's either you are increasing or you are decreasing. So increase. To increase the salary. Decided to increase the salary by 200 cedis every year for the next 5 years. So his HR decided to increase the salary by 200 cedis every year. So this is what the arithmetic gradient is. HR has decided to increase. We said the arithmetic gradient is when there is equal amount received or paid is increased or decreased by a specific amount. So this 200 is a specific amount. This 200 is a specific amount. It is increasing by 200 cedis, right? So that is a specific amount. Assuming it is a percentage, then that will be for the geometric. So when you get to the geometric, that one will be for when there is an increase or decrease in a rate or the percentage. Right. So every year for the next 5 years, if the required rate of return is 15, sorry, let me say 5%. Is 5%. If the required rate of return is 5%, calculate present value. Calculate the present value. Calculate the what? Present value. Calculate the present value. All right. So now, solution. So they are asking us to calculate the present value. So what is the present value? You know that this question, first question is ask ourselves, is it an annuity question? Yes, it is an annuity question. Because could you receive 1,000 cedis salary every year? So every year, could you is receive, right? That is annuity, where you receive equal cash flow in a constant interval, right? All right, so that is annuity. Then his HR has decided to increase the salary by 200 cedis every year for the next 5 years. So the increment in the salary by a specific amount makes it arithmetic. You are going to use the arithmetic formula to compute the present value. That is, the present value is equal to what? The present value of annuity. This is an increase. Look at this. This is an increase. The formula, I said that increase or minus, plus or minus. I said plus or what? Minus. But then this question is an increase, not decrease. So it means we are going to use plus. So plus what? The PK. But then what is our PA? PA is the A over I to bracket 1 plus I n minus 1 all over 1 plus I n. So then what is our A? The A is the equal amount paid or received. So here Kojo receives 1,000. So this is the A. That is the equal amount that Joe is received. So that is the 1,000 for the annuity all over the I. But the next question is a multiple compounding. No, it is not a multiple compounding. The first video I talked about multiple compounding. So if you go and watch the previous video, you know what I mean by the multiple compounding. So here it is every year, so it is not multiple compounding. Multiple compounding. And if you are watching the video, make sure you subscribe to the channel as well, and then you like and comment. If you don't do that, then you are telling us that you don't like the video, so we shouldn't waste our time and do it, right? It's just we're just wasting our time, right? So just like video and subscribe to the channel too. If you cannot do that, then I don't know what you can do. All right. So the interest is 5%. If the required rate of return is 5%, so the interest rate is 5%, right? 5% is the same as 0.05. It is not 0.5. 0.5 is 50%. 5% is 0.05. If you bring 0.5 with you, so everything you are doing is wrong. Take note of that. Sometimes it's we use 0.5 instead of 0.05. Okay. Then 1 plus 0.05. And what is the number of years? Number of years is what? Is 5 years. Is 5 years. In 5 years minus 1 all over 1 plus 0.05. So what are you getting from this? This thing, you punch it as you see it. You punch it as you are seeing it on the screen. Bigger bracket, then smaller bracket, 1 plus 0.05, everything. If you punch it the other way, you get a different answer. Punch it, everything, verbatim, as you see. So what are you getting? I'm sure you are there with your calculator. All right, then let me.
4,329.
What did you get?
4,329.
4,329. That's all. 1 point something. Bring at least two or three decimals.
0.48.
0.48. All right. If the present value the present value. Now let's quickly go to the pk, the gradient. The gradient, we said the k is the gradient. The gradient here is 200. The gradient here is what? 200 cedis. 200 cedis. The 200 cedis, and let me write the formula again. I squared. This formula should be on your fingertips. Even if you sleep and they will wake you up, you can mention it. Right. So the k is 200. That is, it increases by 200. And then the interest rate is 0.05 squared. So bracket 1 plus 0.05. Number of years is 5 years. Then 1 plus 0.05. Number of years is 5 years. Minus n is what? 5. Multiply 0.05 minus 1. Okay, so according to my calculator, I'm getting 1647.38. All right. So now, to get the total present value, that is the PA plus the PK, giving us the 4329.48 plus 1647.8. We have, that is giving us 5976.86. So this is the present value. This is the present value. All right, so let's quickly move to the geometric. This is how the arithmetic is. The question will not tell you using the arithmetic. No, 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 no. The question will never tell you using the arithmetic. No. Even if you get a question that tells you, then it will just be, that is not the common thing. The common thing is that they will just give you the question. You have to have it in your mind that when they say the question says that the amount increases by a specific amount. So let's say by 1,000, 1,000, or by 800. That is a specific amount. And then when it decreases by a specific, you know that you are going to use the arithmetic formula. So now let's talk about the geometric. Any question? Any question?
No.
All right. So if no question, then we proceed with a gradient, with a geometric gradient cash flow. So with a geometric gradient cash flow, this is where equal payments. So let's say the equal amount paid or received changes by a constant rate, changes by a constant rate or percentage or a percentage. So as I said earlier, that the geometric gradient changes by a constant rate, right? So now for the geometric, we have two formulas. What are they? That one also works with the present value. It also works with the present value. So here we have A1 minus into bracket 1 plus g all over 1 plus I, bracket close, or exponent n, all divided by I minus g. So when do we use this formula? We use this formula when the growth rate given in the question, they will give you the growth rate. So it changes by 20%. So the 20% is the growth rate, right? 20% is the growth rate. So when the growth rate is not equal to the interest rate given in the question. When the growth rate is not equal to the interest rate given in the question, all right? That's why we use this formula. And then there's another formula which is the present value, the total present value is equal to A over N over 1 plus I. A multiplying N over 1 plus I. When do we use this formula? We use this formula when the growth rate is equal to the interest rate. When the growth rate is equal to what? The interest rate. The first one, when the growth rate is not equal to the interest rate, right? Note that J is equal to the growth rate. The growth rate, right? So let's take an example. Some of the examples are past questions, right? So, example, the academic fees, for University of Ghana, the academic fees for University of Ghana is currently 4,000 cedis, which is said to increase by 10% for the next 4 years. The academic fee for University of Ghana is currently 4,000, which is said to increase by 10% for the next 4 years. Calculate the present value. Calculate the present value if or let's say if the interest rate is A, 6%, B, the interest rate is 10%. So the academic fee for University of Ghana is currently 4,000, which is set to increase by 10%. Right? So what comes in mind? When you see a question like this, what comes in mind? Or what will come into your mind when you see a question like this? From the explanation that I gave, what will come to mind? Hello? What will come into your mind when you see this question like this? Are you with me? Hello, are you with me? Yeah, what will come into your mind when you see a question like this? Hey, am I on my own or we are together? Okay. So what will come into the mind is that there will be the geometric gradient cash flow because it is increasing by a rate. So here the rate is 10%. It is not a specific amount like the first one. It's not a specific amount like the first one. So the growth rate makes it a geometric gradient cash flow. With the A, the interest rate is 6%. Comparing this interest rate to the growth is 10%. It means the interest rate is lesser than the growth. Or the interest rate, it is not equal to. So here the interest rate is not equal to the I. So what formula are we going to use? We are going to use the PT is equal to A into bracket 1 minus 1 plus G all over 1 plus I exponent N all over the I minus the G. All over the I minus the G. Right. So here our total present value is 4,000. And then we have 1 minus into bracket 1 plus G. G is the growth rate, which is 10%. All over 1 plus the interest rate, which is 6%. Then the number of periods is 4 years. The period is 4 years. So our N is 4. N is 4. All over the interest rate, which is 0.06 minus 0.10. And that is giving us what? So according to my calculator, that is giving us 1597.43. That is the A. What of the B? B is saying that where the interest rate is 10%. So the interest rate is 10%. And what is the growth rate? The growth rate is also 10%. So here the G is equal to the I. If the G is equal to the I, then what do we use? Then we are going to use the PT is equal to A is equal to N over 1 plus I. So then what is our A? A is equal to 4,000, and that is multiplying. That is multiply N. N is number of periods, which is 4, all over 1 plus the interest rate, which is 0.10. 0.10. And this is giving us what? So according to my calculator, this is giving us 14545.45. So that is it. And then we will quickly move to the last type of cash flow, which is the perpetuity. The perpetuity. The perpetuity cash flow. Perpetuity cash flow. So with the perpetuity cash flow, people equal amounts are paid. Equal amounts are paid within equal intervals. Within equal intervals forever. So you are paying the amount forever. You are paying it forever. You pay it till you die, like forever, right? That is the perpetuity. So what is the present value for the perpetuity? Present value for perpetuity is A over I. Present value for perpetuity is what? A over I. Present value of perpetuity is A over what? I. Okay, so now let's take some example. Example 1. What is the present value of 500 cedis paid each year? What is the present value of 500 cedis paid each year forever? The key word you should be looking at is forever. You are paying it forever. That is the perpetuity. If the interest rate, so the perpetuity has the simplest formula, A over I. That is all. Perpetuity. So you cannot get perpetuity question wrong. But that has the cheapest or the easiest formula, right? If the interest rate is 12%, right? So how do you get the present value of the perpetuity? That is the A over I. What is our A? A is 500 divided by the interest rate of how much? 12%. What do you have?
So I got 4166.60.
Uh, So that is the perpetuity, and that is the easiest. That is the easiest. Now let's move on to, we are done with the annuity and then the types of the cash flows, right? Types of the cash flows. Now we are moving on to the next subtopic, which is called the sinking fund. The sinking fund and the amortization schedule. Sinking fund and the amortization what? Schedule. Amortization schedule. That is the next subtopic under the financial mathematics. So note that in the financial mathematics, we discussed the cash flow diagram. We looked at the compound and simple interest. We look at the time value of money, right? And then we look at annuities. Then we look at the types of the cash flows, right? Now we are moving to amortization schedule and the sinking fund. Amortization schedule and the sinking fund. But before that, any question from what we discussed? Any question? Any question? No question. Okay. If there are no questions, then I proceed. To the sinking fund, what is the sinking fund? What is an amortization schedule? What is a sinking fund? What is an amortization schedule? I think I would like to pause this recording and then start the sinking fund amortization schedule in the new video. What do you think? What do you think? Should I continue with the sinking fund in the same video, or I end it and then start the sinking fund and amortization schedule in a new video? Okay. If you are
Record this in the video so that those who come, they'll know that this for this for this.
okay. So, so we would like to look at sinking fund and then amortization schedule. Sinking fund and amortization was schedule. So what do we mean by sinking fund? What do you mean by the sinking fund and the amortization schedule? So what is a sinking fund? Sinking fund. So this is the sinking fund is a contribution. It's like you making a contribution and a contribution of equal amount. Like the example that I give. So the sinking fund is like the susu that I talked about earlier. When you are contributing some amount into the susu box, right? That is the sinking fund. So this is a contribution of equal amount into a fund within equal intervals. To accumulate capital or money for the payment of a loan or to engage in a project or to invest in a project, right? So the sinking fund is where you make equal payment or equal amount into a fund. So the example that I gave was the susu box, where you keep regular payment, specific amount, equal amount, 100 cedis every month, 100. Once you are keeping that same 100 cedis throughout, right? That same 100 cedis was throughout. That is the sinking fund, right? So with the sinking fund, note that usually always compute the equal amount. Compute the equal amount to be paid into the fund. Always compute the equal amount to be paid into the what? Into the fund. Using the future value of annuity what formula. Always compute the equal amount to be paid into the fund using the future value of annuity what formula. Right? Because you are making some contributions now so that you get some money in the future to be able to meet an obligation, right? To be able to meet an obligation or maybe an expenditure, right? So what is the future value? So that is the future value of annuity. What is the future value of annuity? Which is A over I, then 1 plus I, n minus 1. And of course, it will be at the end. We use the future value at the end, right? Unless maybe the question says that it's at the beginning. Once it's silent, we assume that it's at the end. Someone is giving us feedback. Everyone please mute him or herself if you're not talking. I think I have to do that. Okay. So now, we said that always compute the equal amount to be paid. We mean that always compute the A. What is the A? The A is the Fn times I. That is making A the subject, right? To make A the subject, what do you have? 1 plus n minus 1, right? So always compute the A. But that's the equal amount you'll be paying into the fund. So you want to know the equal amount you'll be paying into the fund to be able to accumulate the amount that you need at a future date, right? The amount that you need at a future date. So let's take an example. Philip wants to buy a saloon car for a commercial business. For a commercial business. In 3 years, time, at a cost of 30,000 cedis. At a cost of 30,000 cedis. If the required rate of return, is 10%, calculate how much she would contribute every year. How much you will contribute every year. Full stop. Show your answer using the sinking fund. Show your answer using the sinking fund schedule. Using the sinking fund schedule. So what is the future value? So here, because definitely we are going to use the future value of annuity, right? Because it's asking us that how much would Philip have to accumulate currently to be able to get the 30,000 in the future, right? So the future value has been given, which is what 30,000, and then we have the interest rate. The interest rate is what 10%. What else? Then we have the number or the period, which is it 3 years? Yeah, 3 years. What then is the equal payment? We don't know the equal payment. Since we don't know the equal payment, then we are going to find the equal payment. We know the future value formula to be A over I, and is at the end, so 1 plus I n minus 1. So making A the subject, we have the future value times the interest rates all over what? 1 plus I n minus 1. So then, what is our future value? Future value is 30,000 times the interest. Interest is 10%, 0.10. Then we have 1 plus 0.10. The n is what? 3 minus 1. So, according to my calculator, I have 906.44. 906.44. Now, how do you show this? On the sinking fund. How do you show this on the sinking fund? So the sinking fund schedule. The sinking fund schedule. So for the sinking fund schedule, we have the period or the years. Or let me say the period. So here the years. The year, and then we have the amount at the beginning. Amount in the fund at the beginning. Amount in the fund at the beginning. Then the interest rate. The interest rate, which is 10% from this question. And let me see the interest, not the interest rate. Let me see the interest. The interest on the interest, which is 10%. What else? Then we have the annual payment. The annual payment. The annual payment or the equal payment. You can say the annual or the equal payment. Equal payment, right? The annual or the equal payment. So the equal payment, then we have the amount at the end. Amount in the fund at the end. So amount in the fund at the beginning, or this can be principal, and then the interest on it, the equal amount. So equal payments, right? Equal payments. Now for year 1, we have 3 years. So year 1, year 2, year 3. In the fund, what is the amount at the beginning? The amount at the beginning when we were starting with the Susu boss or the Susu Congo, when we were starting, how much was in the fund? 0. Nothing is in the fund, right? When you are starting your Susu, 0. Any interest on that, the interest rate is also 0, right? the interest rate is 0. Then you made